Hey, hello, welcome to my channel. In this video, we want to find the antiderivative of 1 over x times the square root of x raised to the power of 100 minus 1. Okay, so you can pause the video and try this first. Well, you notice something here. We have the square root of x to the power 100 minus 1, right? Can we make use of the secant substitution, when we have x raised to some power minus 1? No, because in that case we usually have x to the power 2 here, right, under the square root. Then we can try to see saying x should be secant theta and so on like that. But here it's raised to the power of 100. How can we get a single perfect square under the square root so that we can, the square and the square root will cancel out, Well, if that doesn't really seem to work and you can't really get something out of this, let's say 1 over x times 1 over this, integration by part, no, it won't work, right? So what do we really do? Well, as I said, some of my videos, right, previous videos, that integrations you may not really know how to get started, but you just need to try some things, provided you know the techniques, right? That's why they are called techniques. So we're going to try the use up here, and I'm going to call you the whole of this square root of x raised to the power of 100. So let's see what we have. So I'll say let u be the whole square root. Since it wouldn't make any sense for me to say u should be the inside, there'll be nothing to cancel out, or neither outside, right? So let's just say the whole of that square root of x raised to the power of 100 minus 1. So since we have that to be u, okay, the next thing is to differentiate that. So the derivative of u with respect to x will be, well, when you differentiate the square root of something, you have 1 over 2 times the square root of that same thing, right? That will be x raised to the power of 100 minus 1. So the derivative of the square root will be 1 over 2 times the square root of, just repeat it, right? Okay, but here we are going to use the chain rule, because inside this square root we have another function of x. So that means we're going to differentiate x raised to the power of 100 minus 1. X raised to the power of 100, the derivative will be 100 x raised to the power of 99, right? Then minus 1, of course, we just leave it like that. So we put the dx over here instead of here. Let's just put it here at once. So maybe we can, from here we try to make, let's see. Okay. From here we try to make dx subject of formula, right? That is, we can take the reciprocal of this and then replace, interchange dx and du. That will mean we're going to have dx to be, when we take the reciprocal of this and interchange this and that, we're going to have 2 times the square root of x raised to the power of 100 minus 1. Okay, we divide that by 100 times x raised to the power of 99. Then we put the du over here. So why we're doing that is because we want to get a replacement for dx, right, and some other terms. So let's see what we have. So this is going to be equal to the integral of, well, let's notice at the top we just have 1, right? Now this is x, let's just keep it there. Now this is the square root of x raised to the power of 100 minus 1. We call that u, right? So that should be u, not u, like u, right? Okay, great. Now dx, in place of dx we're going to put in the whole of this. That will be 2 over 100, which is the same thing as 1 over 50, right? Let's just do it little by little. 2 over 100, and then the square root of, let me put it at once, x raised to the power of 100 minus 1, right? Then we divide that by x raised to the power of 99. Then we put the du over here. So the essence of this change of variable, the use up, is to change the variable from the x variable to the u variable. Reason is we want to make this integrand to be a little bit complicated, right, or something that we can handle. So we try to make a suitable substitution for that. Okay, great. So you notice that at the top here we have square root of, the square root of x raised to the power of 100 minus 1, which is exactly equal to u, right? So I'm going to replace this term with u. Keep in mind that this is 2 over 100, a constant multiple, which we can put it out of the integral sign, and it is going to become 1 over 50, right? Okay, so at the top we're going to have 1 times u, because you notice that this term, this square root term, is exactly what we call u, right? Then we divide that by, well, this is x, right, times x raised to the power of 99. That will be x raised to the power of 100. Then we multiply by this u over here. The 100 and the 2 will be pushed out of the integral sign. So as we can see, the x and the u will cancel out nicely. We're going to have 1 over 50, then the integral of 1 over x raised to the power of 100. We put the du over here. So as you can see, we are still having a term in terms of x, but we want to integrate over the u variable. And you know that we can't treat x as a constant because x and u, okay, are related to each other. They are both variables. So we need to make sure that we replace this with something in terms of u. And that's so if we get x, make x raised to the power of 100 subject of formula from this particular equation. So from that equation, you keep in mind that if we take the square of both sides, we are going to have u squared to be x raised to the power of 100 minus 1, right? So we are going to add 1 to both sides. That tells us that x raised to the power of 100 will be u squared plus 1. So in place of x raised to the power of 100, we are going to put in u squared plus 1. That shows from the formula, the substitution we started with. So we're going to have 1 over 50, okay? Then the integral of 1 over u squared plus 1, or you can, if you like, you can say 1 plus u squared, and then we put the du over here. This is very nice. This is very nice because when we have 1 over 1 plus u squared, it is gotten from the derivative of tangent inverse of x. So the antiderivative of tangent inverse of x, okay, in this case it's going to be u, will be, excuse me. Now when we have the integral of this is equal to inverse tangent of u. The reason is when we differentiate inverse tangent of u, we get this integrand, that is 1 over 1 plus u squared. So that means that the antiderivative of 1 over 1 plus u squared will be inverse tangent of u together with the 1 over 50 out front. So we're gonna, since we are done with the integration, we just add an arbitrary constant. But you notice that this is u, right? We need to get back to the original variable, which is the x variable. So in place of u, we are going to put in the square root of x raised to the power of 100 minus 1. So let me just put it up a little bit. This was 1 over 50. Then the inverse tangent of u, where u is square root of x raised to the power of 100 minus 1, right? So since we are done, we can add an arbitrary constant, and this right here is the antiderivative of that function. All right, great. Okay, so it's crazy, right? It's very simple, not as the equation appears or seems to be. Okay, so thanks for watching, and if you like this video, please do well to subscribe to my channel.